Welcome to a numerous WebKit SIRS epidemic modeling web app. This is instructional video 2. In this video we will show you how to select the fitting mode of the app, format and load SIRS incidence data, set up a least squares or maximum likelihood estimation process, implement the fitting process, and save the results for future studies. Before proceeding, the user should be familiar with the run mode implementation of the app. See instructional video for further information on this. When the app is opened, it will be on run mode, and here's an example of a simulation. Now, once you're on the run mode, you can switch to the fitting mode. The SIRS model is fitted to incidence data. We have a test data set available for the user. This data set comes from an Ebola study and is implemented in terms of loading a CSV file in which the first column is the time steps. In this case, the time steps are considered to be weekly, and the second column is incidence, so this is weekly incidence. You can either load your own data or you can load the test data. So we're in run mode, and now we're going to switch to fitting mode. In this mode, we can download the sample data. We can save it on our computer. We can then load this data for use by the app. This data can be manipulated by adding zeros to the end by changing the fit interval. There, for example, you see zeros added to the end of the data. And one can shift the data so that the data start at week 6 or week 8 or the time interval of your choice. Here is how we go about loading the data. We select fitting mode. We can download the available sample data. We can save these data and then load the data into the app, or we can load our own data. Here you see the data appears as two columns, a time column and an incidence column. We can change the interval by adding zeros to the end of the data, and we can also shift the data so that the first incidence case starts not at week 1 but at a week of our choice. Then we can move on to selecting parameters and setting ranges for the estimation of these parameters. We'll also select the method, and we have a choice of least squares or maximum likelihood estimation. We use these buttons to select between maximum likelihood and least squares estimation. We check or uncheck these boxes to select the parameters involved in the optimization. Those are not selected. We'll use the slider value indicated over here. We can then edit the parameters to get the maximum or minimum values for over the optimization range, and also two initial guesses We can either have random guesses or we can put in the actual values. So those are random guesses. If, for example, the initial population size or baseline contact rate, we want to put in our own values, we can do that as well. Okay, once these values are in, we can initiate the optimization process. We do this by setting up the parameters of the run, the maximum number of runs, the tolerance or numerical step size, the minimum error that we'd like the solution to converge to. Then we load the data, and we can set the interval. We'll set the interval to 60 in this case by adding zeros at the end, and we'll shift the data to week 8, which means that the first case was observed in week 8, even though the epidemic started earlier. Now we'll start and we'll monitor the number of runs that are being made, and we'll watch the convergence process. Initially, it takes a while for the solution to start to look like the data. If we run it for long enough and it appears that it's either not converging or it's stuck in a local minimum, as is the case over here, where we don't seem to be making any progress in the value of the optimization, then we can restart the optimization and either change the numerical step size or tolerance value or edit some of the parameters and start with new initial guesses. So we'll improve on the starting conditions. We'll first change the tolerance so that we get larger step sizes in the optimization. We will reset the baseline contact rate by guessing between values of 0.1 and 5, and then we will start the optimization and we will let it run, and we see that very soon the fitted curve starts to move up, which is a promising sign, and we'll continue this process and will eventually begin to converge on a final solution. Here we're at run 235, 230, 240, and so on. And we'll let this run for a bit. And then finally, the algorithm will stop once this tolerance level has been achieved for a minimum error. And so the final solution is now occurs at run 437, and we see that the action is done. These values over here can be saved, so we can accept the values by pressing on the accept option button. And we can do a run of the model with these saved parameter values. We might change the simulation length so that we can see more of the epidemic and complete a run. We can also save the estimated parameters as one of our presets and use these in further studies. Example, if we want to do a vaccination study. This is the end of video 2, and we thank you for your attention.